All right, so this will be our last lesson for this unit. And we're going to start just by reviewing some properties that you would have learned about in Algebra 1, but it's probably been a while. But they'll help us with what our lesson is about today. And then also they'll help us moving forward because we'll be using them a lot in the upcoming units. But these first 4 properties of equality are basically just how you solve equations. Every time you're doing a step to solve an equation, you're using one of these, even if you haven't been talking about them. So if I have an equation that looks like this, as long as I add the same amount to both sides, so I'm going to add C, whatever I do to one side, I have to do to the other side. And so what this is demonstrating is the addition property of equality. If we think about it in terms of one that maybe looks a little more familiar, maybe something like this. So if you were solving this equation, you would see that -2 there, and you would do the inverse. You would add the same amount to both sides of the equal sign, so you would be using the addition property. So as long as you're adding the same amount to both sides, you're using the addition property. So subtraction property is just subtracting the same amount from both sides. So I'm just using variables here to show that it can be any number, as long as it's the same number. So C in this case is the same amount. I'm subtracting it from both sides, so I'm keeping that equation equal. All right, whenever you solve an equation, if you multiply the same amount to both sides, so once again, I'm just using C to represent any number. As long as you're multiplying the same amount to both sides, you're using the multiplication property. And then finally, when you're solving an equation, if you divide the same amount from both sides, then you're using the division property. So you've probably solved one like this where it was like, 3x equals 12, and so you're dividing this side by 3. You're dividing this other side by 3, so you're using this division property. You're keeping it equal by doing the same thing to both sides. So any questions for me so far? Okay, so once again, we're on page 15. All right, so distributive property, oftentimes an easy way to recognize it, there's going to be parentheses. That might be your clue that you're looking at the distributive property. But you just want to check and see what it looks like afterwards. So if I distribute this A to both things inside the parentheses, I would have A times B, plus I'd also have A times C. So you'll be able to recognize the distributive property if you have the before and the after. Questions from me so far? Okay, so for substitution, you've been using that a lot, especially when we've been solving for angles. And so you would solve to figure out how big x was, and then you would plug x back in. Anytime you're replacing, so if I take an expression and anywhere I see an A, I put a B instead because I know they're equal to each other. Anytime you're replacing like that, that's the substitution property. Okay. In my experience, these next 2 are ones that students often mix up, so I'll try and give you some ways of keeping them straight. But the reflexive property, maybe think about reflection. And so if I'm looking at my reflection in the mirror, I'm looking at myself. So the reflexive property just shows you that something is equal to itself. So this is me, this is my mirror image, so I'm looking at myself, that's my reflection. That might be an easy way to remember reflexive. All right, and then this symmetric property just allows me to say that if these 2 things are equal to each other, it doesn't matter which side of the equal sign they're on. I can switch them and say this. And so you've probably used this a lot when you were solving equations. So for example, if I were solving an equation and it looked like this, and I was trying to get x by itself, so I divided out that 2 from both sides, and I got 9 equals x, you may have flipped this around and said, well, if 9 equals x, that means x equals 9. And so you're using the symmetric property when you do that to put the variable on the left side. And so a way to remember this is notice that symmetric sounds like symmetrical. And so notice if I were to draw a line between these two things, they are symmetrical. If I were to fold this over, B would land on B, the equal sign would land on the equal sign, and A would land on A. So they're symmetrical. They're just switching which side of the equal sign it's on. Questions for me? Okay. The last one is the transitive, and oftentimes it'll just have 3 statements. There are some other ones that have 3 statements, but that will be your clue that maybe it is the transitive. But it's just where I have 3 things equal to each other. So if A equals B and B equals C, and it's kind of like the law of syllogism. My last statement is just going to be connecting the only 2 things that haven't been connected yet. So if all of these things are equal, that means that A equals C. All right. So we're going to be using these properties a lot moving forward. So I'm going to scooch this down just so you can see any ones that you would like me to talk about a little bit more. Any ones that you're not sure about? Okay. So in that case, I want to give you a little bit of time just to see, are you comfortable recognizing them? So, for example, this first one, I'm noticing that I have k equals 3, and now it's switching which side of the equal sign it's on. Can someone talk to me about what would be the property that's being shown there?
I think it's the symmetric property.
Good. So that would be the symmetric property. Another way I can tell is that if I were to draw a line between these 2 things and fold over, 3 would land on 3, equal sign would land on equal sign, k would land on k. It is symmetrical the way that it's written. So that might be a way to kind of remember it. If I look at one like 2, if you're a little bit stuck, maybe try solving it yourself. So I'm noticing that from here to here, x is by itself now. So I would just go back and think about how would I get x by itself. So I'm noticing this is multiplication. So I would do the inverse and I would divide. Whatever I do to one side, I would do to the other. And that would give me an x. 14 divided by 2 would give me 7. So that's definitely what they did, even though they didn't show the step. So they were using the division property. So they were just dividing out from both sides. And notice I'm just kind of using a little bit of shorthand. You can as well if you want to shorten some of these words. The important thing is, can you figure out which properties are being illustrated? So I'm going to walk around. I'm going to give you a little bit of time just to see how far you can get on this page. We will check some of these probably in about 5 or 6 minutes. All right, so I'll walk around. Anything you want help with, just let me know. I'm seeing lots of great work with these. If you're wanting help, let me know.
It's a plus.
We're going to check something for you.
Oh, I can switch the traction.
Double check 9. Do you mind if I do this? Yeah, you already found them when you said you were just switching the two of them.
Did you stop the states that you guys would believe?
Oh, I thought you were adding
They're always
together.
the same four, they keep they got everything.
No, I never got properties that were this good. They so
It's just us, JD.
Alright, I know we are in different places, but take a moment just to see how you did with the ones that you've tried. I have this key on Schoology, so if you end up wanting to use these later, if there was some that you want to try them before your test to help you review, you can always check it there. But let me know, are there ones that you want me to talk about how I figured out what property it is? Because some of them can be kind of confusing. Just shout out any numbers and I will happily talk about it. Yeah? Alright, so I will talk about 14. So even though we're kind of seeing it a little bit backwards, notice that it's showing that if we multiplied x to that 5, we'd have 5x. If we multiply x to that 8, we'd have 8x. So it is the distributive property. Does that make sense? Okay. What are some other ones you would like me to talk about? Yeah. 13? Yeah. So if it looked like this first and now it looks like this, I can see there's more there. So it's my clue that some sort of operation has been done. So I'd look at, well, if it started out as m and now it's 8m, that's multiplying by 8. If I multiply this negative 2 by 8, I also get negative 16. So I can see they multiplied 8 to both sides, so that would be the multiplication property. Yep. Yeah. All right, let's take a look at 7. All right. So for this one, it started out as 6y equals 24. I can see that it's longer now, so they did some sort of operation. So I would just want to see, what did they do to the 6y? Well, they're taking away 3. What did they do to the 24? They took away 3. Since they're subtracting the same amount from both sides, it would be the subtraction property. They kept it equal by doing the same operation. What are some other ones you want to hear a little bit more about? Okay. So once again, if you try some of these later, just while you're kind of reviewing for your test or anything like that, I have this key on Schoology, you'll be able to get it there. But whenever you're ready, if you can flip over, we'll talk about why we're using this. So in geometry, we're going to work on something called proofs. And in my experience, sometimes they can be a little bit tricky for people. So instead of starting with geometric proofs, we're going to start with algebraic ones, just so you get used to the format and how it works, and that way it'll be easier when we do it later on. But essentially, a proof is you're given a problem, and you're asked to prove something in the end. You're given the beginning and the end, And then you have to figure out the steps along the way, and you have to justify each step with a reason. So we're going to be using all of those properties that you just learned to justify. So a 2-column proof, we have 2 columns. The statements or steps that you're going to do would go on the left side. And right now they're already filled in for you, but eventually we would do proofs where you wouldn't have this either, where you'd be kind of figuring that out also. And then each time you do a step, you have to put your reasoning on the side. That just explains what you did, basically, or why you did it. And so for your reason, you can use properties. And so that's what you'll be doing today, justifying your steps with the properties we just kind of reviewed. But eventually, when we look at the geometric proofs, you can also use definitions that we've learned about. So for example, maybe you're looking at a picture and you know that there's a midpoint. That would help you see that there are 2 equal pieces, because a midpoint slices something in half and creates 2 equal pieces. And so you would put your definition there as just the definition of a midpoint to justify that. You can also use some of the postulates or theorems, kind of formulas that we've learned about. So maybe eventually you're solving something and you use Pythagorean theorem. You'd be able to give your justification using that. But for today, we're just going to focus on the properties we were just reviewing. So they gave me this problem, so I'm just going to start with given. And then I'm going to explain my steps afterwards. And so like I said, this one's already been filled in for you, but if you're not sure what the steps are, maybe start solving it yourself. So I'm noticing if I were solving this equation, I would want to use inverse operations. I would add 1 to both sides. And so what happened between this step and this step is I just used the addition property. All right. So take a little bit of time, see how far you can get with justifying the steps for these. And then you'll have a chance to earn lots of points for your class. So I'm going to check in with you guys in just a couple minutes. Walk around. Let me know if there are things you want help with so far. I'm so sorry, the copy is not super clear, and I apologize about that. This is supposed to be a plus sign before that too. So it kind of looked like a division sign, but it is supposed to be a plus sign. Sorry about that. Those are helping their shoulder partners. Appreciate it. All right, so I want to hear from you guys. What would be the last thing that justifies what happened between 2 and 3? Can I have a volunteer tell me about that? Yeah.
The division property.
Good. So they're dividing both sides, so that would be the division property. All right, can I have a volunteer tell me what happened between step 1 and step 2? Yep. John? Good. They took away 2 from both sides. They subtracted the same amount. So that would be the subtraction property. How do we get from step 2 to step 3? Could I have another volunteer tell me about that? Yeah. Good. They saw division. They multiplied by -6 on both sides. Awesome. Questions for me so far? So I owe you guys a couple points. All right. Can anybody talk to me about what happened between 1 and 2? What property is being shown there? Okay, yeah. Good. That's the distributive property. All right, someone I haven't heard yet, tell me what happened between 2 and 3. Yeah. Good. They're subtracting 27 from both sides. And once again, if you're not sure, maybe try solving it yourself. Think about what you would do, and then verify if that's what happened as well. Okay, the last one. Good. They're dividing out that -18 from both sides. All right. So that is it for our lesson for today. We've officially finished Unit 2. So in that case, you have some time to work on homework right now. If you want to look ahead and you're thinking about like prepping for your test, the review guide is actually going to be in the packet this time. So you could even start on that if you want.
Wait, when's it start?
I'm going to pull up the calendar right now so you can see it. It's at the start of next week. So we'll have ours on Monday, the 30th. Yep.